subscribe the channel. Today we discuss very important theorem of the chapter circle. The name of the theorem is that the angles between tangent and secant. Student, the theorem is that if the vertex of the angle lies on the circle, one side of the angle is the tangent to the circle and one is the secant. At that time, the measure of that angle is equal to half of its intercepted arc. Now, this is the theorem of angles between tangent and secant. Now, I repeat it. If an angle has its vertex on a circle, its one side touches the circle and the other intersect the circle in one more point, then the angle is half the measure of intercepted arc. For this, there are three cases. One is the tangent to the circle one side and another side intersect the circle in other point, which is passing through the center of circle. First case is this side passing through the center of circle. Second case is the center of circle is the exterior part of the angle. And third case is the center of circle is the interior part of the angle. We see one by one cases here. Now for this, I have to draw here the figures. This is the first figure. Here is this angle ABC. The side BC is one side which is the tangent to the circle and this is the secant to the circle. The first case is this side passing through the center of circle. M is the center here. Second case is this is the tangent and this is the secant. AB is the secant. Center M is the exterior of the angle ABC. And in third case, this angle ABC, this is the tangent and this is secant, and this point M is the interior of the angle ABC. At that time, measure of this angle ABC is equals to half of its intercepted arc ADB. Means that we have to prove here ABC is equal to half of intercepted arc ADB. For this, we write its given is that let angle ABC be an angle where vertex B lies on the circle with center M. Its side BC touches the circle at B and side BA intersect the circle at A. Arc ADB is intercepted by angle ABC. To prove it, measure of angle ABC is equals to half of measure of arc ADB. Then there are three cases. If first case is, I have taken its proof. Case first, center M lies on the side of angle ABC. Side of the angle ABC. Then in this figure, M is the center of this. M is lies on this side AB. Therefore, in figure first, I will take the figure first here. For figure first, the center M, the center M lies on the side AB or BA of angle ABC. Now when we look here, this is the tangent and this is the secant. This is segment MB is the radius here. All of you know that the theorem tangent is perpendicular to radius. So that this angle is how much? 90 degree. So that therefore measure of R, look carefully here, measure of this angle ABC is equals to MBC is equals to 90 degree. Therefore angle ABC is equals to angle MBC is equals to 90 degree. Let this equation number first. The reason is that by using tangent theorem. perpendicular to radius, this is tangent theorem, so this is right angle. Then this is the diameter, so this is semicircle. Semicircle is half 180 degree, and this 90 degree is half of this 180. So that from first and second, angle ABC is equals to half of measure of R ADB. Means that first is we have to do here. ABC is equals to half of measure of R ADB. Means that for first case we have to prove that measure of that angle is equal to half of its intercepted R. Now then we take the second case here. I will write here case second. Now in this case second, center M is the exterior. Exterior of angle ABC. If it is exterior, then we have to join these two segments, then the triangle is formed. This triangle, in this triangle MAB, these two sides are equal because radii of the same circle, so that the base angles are also equal. So we take this case here, second case. Means that in this second, means that in second figure, in figure second, center M lies in the exterior of angle ABC. Draw segment, or that is radius, that draw segment MA and MB. Segment MB. Now student, then this angle MAB is equals to angle MBA. Therefore angle MAB is equals to angle MBA, because by using isosceles triangle theorem. Isosceles triangle theorem. Then here is angle MBC is 90 degree. Because by tangent theorem. Let these two angles be X. These two angles be X. Let angle MAB is equals to angle MBA is equals to how many degree? X degree. And this angle ABC is taken in another variable, suppose that Y. And angle ABC is equals to Y. Then student, then I have to find the value of MBC. Then angle MBC is equals to angle MBA plus angle ABC by the angle addition axiom. MBC is 90 degree is equals to MB is X here, and this ABC is Y. Means when we multiply it by 2, we get that. Why we multiply? Because we use this equation to solve this next point here. So first multiply it, we get that twice x plus twice y we have to find here angle AMB plus angle MAB is x plus x is equals to how much? 180 degree. Then angle AMB is equals to AMB plus twice x is equals to, I have to substitute the value of 180 from third, twice x plus twice y. Twice x plus twice y. Here is from equation third. Look carefully, I have to substitute this value of 180 here. Twice x plus twice y. When you observe carefully, this twice x get cancelled. Means that angle AMB is equals to twice y. Therefore, I will write this 2 here is goes to denominator. So y is equals to half of angle AMB. Then I substitute the value of y is ABC and AMB. Look at this, AMB is the arc ADB. First I have to write here. Now angle AMB is equals to measure of arc ADB by definition of arc. Definition of measure of arc. Then substitute the value of y and this angle, we get that y is angle ABC is equals to half of its intercepted arc आला था, कोणता arc आला था? Measure of arc ADB and secant is proved. Means angle ABC is equal to half of measure of arc ADB. I repeat, look carefully. From the second case, M is the exterior of angle ABC. In this figure, second center M lies in the exterior of the angle ABC. So draw these two segments. Then this is the isosceles triangle. These two base angles are equal. Then this is the right angle here. Tangent theorem. Sum of this angle is x plus y. Then is equals to 90. Then I have to multiply it because we use for here. So twice x plus twice y is equals to 180. Then twice x get cancelled. Then it is equals to twice y. This y goes to denominator. I have to write this side and this y is this side. Half of angle AMB. But AME is the central angle. By using the definition of the measure of arc, measure of the central angle is equal to its corresponding arc. So I have to write here the measure of this angle is equals to arc ADB. And re-substitute this value of r and y, we get our second is true. Means that measure of angle ABC is equals to half of measure of r AD. Then we see the third case. Student, this case is the activity base. So I have to take this case by looking this portion. The third case is case third. In this figure, mean that in this third figure, center M is the interior of the angle ABC. At that time, look at this figure. Ray dash dash is opposite ray of ray BC. Ray BC is opposite ray झाला ray B. So I have to write here ray BE is opposite ray of ray BC. Student, then look at this angle ABE. By using earlier these two cases, the measure of this angle is equal to half of this intercepted arc. Mean that arc AFB. So ABE is equal to half of measure of arc AFB. Then look at this angle ABE. Look here, ABE plus ABC is equals to 180 because angles in linear pair. So that when we find out the measure of angle ABE by using this linear pair, then ABE is equals to 180 degree minus this angle ABC. So here I have to write here 180 minus angle ABC is equals to measure of arc half measure of arc AFB. Now look here, the reason is linear here. So when we take this half AFB, AFB is, how to find out this AFB? Measure of arc AFB is equals to, from this total measure of the circle, if we subtract this measure of arc ADB, we get the arc AFB. So the next step is 360 minus measure of arc ADB. Measure of arc ADB. Then this is as it is here. Then when we divide this to this 360, it becomes 180 and half into this as it is. Student, then this 180 get cancelled because the equal side having same sign, so they get cancelled. Here is minus angle ABC is equals to minus half of measure of arc ADB. Minus minus convert as plus, so changing sign, ABC, angle ABC is equals to half of measure of arc ADB, and hence our third case is also true. This is the very important theorem, angles between tangent and secant. Thank you. We take the next point. Now we discuss the next points. Alternative statement of the theorem, angles between tangent and secant. Alternative, baga, here is, this is the tangent and this is the secant here. Mean that BC is the tangent and AB is the secant. At that time, the angles between this, look here, ABC, and to the opposite of that arc is angle ATB. If they are congruent also. They are also congruent, mean that they are also equals. Now this statement is that the angle between a tangent of a circle, and a chord, a tangent drawn from the point of contact मधून आपण chord drawn केली, is congruent to the angle inscribed in the arc opposite to the arc intersected by that angle. Mean that this angle ABC is equals to also half of measure of arc ADB, and this angle ATB is also half of this angle ADB. Mean that these two angles are congruent or equal. So angle ABC is equal to half of measure of arc ADB is equals to angle ATB. We use this property to solve the examples also. Okay. Then converse of the theorem of the angle between tangent and the secant. The converse is that, now look here, here is one side of the angle is the tangent and one is the secant here. Now a line is drawn from one end of the chord आहे याच्या one end मधून एक line draw केली of a circle, and if the angle between the chord and the line is half the measure of the arc intersected that angle, mean that measure of this angle is equal to half of this arc, mean that angle ABC is equal to half of arc ADB, and angle ABE is equals to half of this arc AFB. Then this line, that line is a tangent to the circle. Then this line is the tangent here. Mean that if angle ABC is equal to half of measure of arc ADB and angle ABE is equals to half of measure of arc AFB, then line EC is tangent to the circle. Can you understand this converse?